Hi, this is the ME452 Interim presentation. We're Team 11, and we're doing the analysis and redesign of the food processor. So the product we choose is a food processor, which can be used to chop, mince, shred, and slice foods, and can have a wide variety of uses depending on the attachments used. So for our target customers, our primary customers are home cooks that require the ability to process food safely, efficiently, without the use of a knife. Our secondary customers are professional chefs and other kitchen staff in the restaurant industry, which produce and process a much larger amount of food than the home cooks. So for our function analysis, we made a fast diagram, design our main function to be processed food, and our three main sub-functions to be cutting food, combining food, and storing food. Mm, When cutting food, it is able to adjust size and adjust shape. When combining food, it is able to stir and mix food. When storing food, it is able to contain mixture, prevent spilling, and measure amount.
On the left is an exploded view of the entire food processor, and on the right is an exploded view of the blade shaft subassembly. The numbers shown in the diagram represent the order listed in the bill of materials, which is covered later in the presentation. Here are two possible assembly sequences with another exploded view to help guide through each component. Sequence 1 is broken up into more branches, which allows for better parallel assembly than Sequence 2, since it allows multiple people to work on various components, which can be easily secured to the main body later. However, Sequence 2 is better for transferring and handling, locating parts, and testing each subassemblies as there are less parts moving around between people within the assembly line and combines necessary components for testing. For example, the gears cannot be fully tested for binding without the motor in sequence 1 until it is transferred to the third person in the assembly line, while in sequence 2 it can be fully tested before being transferred to the next person. For fastening and joining components, both assembly sequences will have the same level of difficulty since how they are assembled does not change overall. Here we see how each sequence is ranked in each criterion with a 1 to 3 ranking system, with 1 being the worst and 3 being the best. Ultimately, with the information mentioned in the previous slide, we came to the conclusion that sequence 2 was the better assembly sequence due to it having higher rankings for transferring, handling, and locating parts, as well as the testing of each subassemblies. Shown is the function component mapping matrix. From the table, we can see which functions are most important, such as stir food, mix food, provide protection, and facilitate cleaning. We can also see which functions are less significant, such as measure amount and display warning, as they only have one component representing it. We can also see which parts may be modified in the future, as components such as the base plate, cover pin, top housing, and gear caddy only falls under one function.
Now we will begin talking about our bill of materials. Before we go through our bill of materials, we're going to state some assumptions that we have. Firstly, our batch size is 9 million units. We're going to be focusing our bill of materials on the consumer variant. Secondly, average injection mold is about $20,000 per part due to our simpler shapes and smaller sizes for our parts. Our custom punch dies are about $500 since our punches are also very simple in shape. And averaging all the carbide milling bits that would be used across any machining would be about $100 with a tool life assumption about 1,000 parts per tool. This is our bill of materials. So you can see here, most of our materials are made from ABS plastic, with a lot of our manufacturing processes focused on injection molding. Next here, we can see our second half of the bill of materials with a little bit more focus on stainless steels. And we do have a few notable parts that were purchased, such as our gears assemblies and switch assemblies. You can see here on the bottom right that the total unit cost is $21.84.
For function differentiations, we found that for our customers, the function of cutting good, containing mixtures, size or shape adjustment, and measuring are the most commonly needed. However, some other customers may looking for food processors that can mix food, maybe with a larger volume or better power, or just less noisy than other products. As for component commonality, we have break down the different functions to modules that we can actually change for product family design. They are the football, motor, and attachments. The blades to be specific.
Before I go into the product family redesigns, I would like to mention that the motor will change between the two variants, but since it is purchased, it will not have a redesign. So the home cook version will be slower and more quiet, while the commercial version will be powerful and faster. For the following slides, the initial CAD model is on the left, while the redesign is on the right. The first redesigned part was the blade attachment, and for the home cook version, there will be various interchangeable attachments for different purposes. The one shown here will be a whisking attachment, which works well with the slower motor, and there will be other types of attachments as well. For the commercial version, the product will only come with a single blade attachment, and these blades will be made out of a more durable material. There are more blades to allow for faster processing speed, which aids with a higher output volume. The second redesigned part is the food bowl. For the home cook version, a handle is added so the user has an easier time handling the product. For the commercial version, the food bowl is taller, which allows for more objects to be processed at once and allows for a higher quantity of stored objects, and that benefits the high volume that restaurants need to supply to its customers. Here are the variants side by side. There is guaranteed interchangeability between them. For the attachments, there is a mechanism that allows them to attach and detach freely to aid with the cleaning process, and the redesigns will be compatible with this. For the food bowl, there are slots at the top and bottom that lock with the food processor cover and food processor base respectively, and the redesigns will keep their original slots so that they can be seamlessly used.
At last, we have the same assembly sequence as the product family, just substitutes the original parts, but not combining or dividing. As the primary and secondary shows in the slide, they both start on the base plate, differs at motor, simultaneously going forwards till we have the whole food processor. Thank you for watching.